now for something completely different, because it's not actually. This is coming from a completed project. The construction of our corpus was a bit painful, but not as painful as what you just saw. And we're going to encourage you, even from the start, to visit our slides and our project. We want you to click in there and move around. The interface stuff does matter, and I'm kind of delighted this panel just kind of makes a lot of sense. So here we are. There will be a QR code at the end. The Frankenstein Variorum project has goals as research questions. We wanted to upcycle or connect previous digital editions of Frankenstein that had been done some in the 1990s, as you'll see, and up to 2013. And we wanted to compare or collate them in a way that demonstrates a non-linear, divergent, or forking and branching edition history. We wanted to be able to display that in a good interface to encourage exploration from one edition to the others. All right, what do we mean by a variorum? That's a fun word to pronounce early in the morning. Our most immediate context is Barbara Bordalejo's very important Darwin Online project, and she consulted with us early on this. Our project is kind of similar to hers. We compare 5 versions of Frankenstein to Darwin Online's 6. But we're different because we're incorporating some manuscript witnesses with some fierce markup in them. And we're integrating earlier digital editions made by others. So Barbara kind of created those editions. I am what? Is that better? Okay, I'm not sure. Okay, it's too loud for Meg. Okay, so Frankenstein integrates earlier digital editions made by others so that we were working with already created edition work that we were pulling together into our project. So we need to visualize a collation, a comparison of versions, working with digital editions that were encoded very differently. We are also designing from the beginning a static website for serendipitous browsing and intensive research. In a lot of ways, this was a joy to work on because we thought of the interface from the very beginning of this project. We wanted to apply the TEI in a very deliberate way to be delivered in a JavaScript context to store our comparison data and pointers to variant passages. Okay, I'm not going to read all of this, but I want you to just kind of see this as a timeline. These are the projects on which our Variorum is built. And I want you to notice the cluster of projects in the mid-1990s that made everything possible. There's a really important Pennsylvania electronic edition that was one of the very first experiments in hypertext format to compare the 1818 and 1831 editions. Without that, I mean, that was the beginning. Jack Lynch and Stuart Curran's work. Also, Charlie Robinson and Nora Crook working with the Thomas copies. That was a move in the 1990s to make everyone aware of the earliest versions of Frankenstein. Prior to that point, most people who read Frankenstein had read the 1831 and didn't know about the earlier ones. If you went to school after that and got assigned Frankenstein in a class, probably you read the 1818 thanks to that edition work in the 90s. Okay. And that's just a glimpse. We have written and published about this in other places, but that's a glimpse of how very different editions have been made about this. The one on the bottom is Raf Viglianti worked on this one, the Shelley Godwin archive, which was a surface page, line by line diplomatic edition of Mary Shelley's fair copy of Frankenstein. And up on the top left is that really cool hypertext edition, which is still alive. You could go visit it. Love it when the old ones survive. All right, we did create 2 new digital editions in the Variorum. There's new encoding of the 1823 edition, thanks to Carnegie Mellon University librarians who did, I think, non-destructive scanning from a Google Books copy for us and made good OCR. And Rick Mulligan led the way to make sure that that happened. And then I prepared a new edition of the Thomas copy on top of our code for the 1818. So this is my quick discussion of the 1823. The Thomas copy, I went to the Huntington Library and read Mary Shelley's Marginalia, scribbled in a copy of the 1818 text. And these were changes she thought she might want to make in the novel, left that book behind with a woman named Mrs. Thomas in Italy, and never looked at them when she made the 1831 text, as far as we know. But we have that copy at the Huntington Library, and it is marked there. So I just basically did my transcriptions, consulted Nora Crook's work and James Rieger's work, and incorporated that in add, del, and note elements in the edition. So preparing for collation was a lot of work. I'm going to move through this very quickly. But we learned it is best not to collate the entire novel files. You've got to cut them into pieces. It's very important. And we created 33 collation units. Edition files of the same unit are chunked together. And one reason this is absolutely necessary is that the manuscript copy is not complete. So we needed to line up what we had. And for more detail on any of this, I got it all written up in a lot of detail on our methods page on the site. Go read it if you're going to start a project like this. You've learned a lot. We have a very big Python collation script to help us figure out, this is where we express our theory of similarity. How do we mark what aligns and what differs across the 5 editions? So a big effort with this is, what is our theory of normalization? What things are equivalent to what other things? And that's got to be something that you think very carefully about in a project like this. We prescribed output in the form of the TEI critical apparatus. And I put a link in there if you're not familiar with it, but it allows us to create an XML file that coordinates every moment of variance across the 5 works. And on that, we built our big project. So let's move through this. That made it sound really easy, right? It's more like this. I made this from a couple of, it's a little artwork that I created. I just want to express a caution. This did not take a year the way we thought it might. It took between 2018 and 2024, 2017 and 2024, roughly. Snags and tangles. That's the creature 1818 illustration of him inside a tangled up machine loop. And we needed our students to help us do this rationally. I'm serious about that. So students led the way in saving our sanity on this project and helping us to finish it. So they first explored the development of contextual annotations. We're not displaying those because I'm not sure that portion was complete. But more seriously, since I moved to Penn State, generations of my students helped us to track and categorize the kinds of tangled up collation errors we would run into. Yuying, who is our third co-author of this paper, helped us find algorithmic ways to debug the collation tangles. You don't want to correct every single error by hand, no. We created, and see our other papers at our methods page for this. But we had a student senior design project to finalize the interface after helping us clean up our data, and that was huge. So what did we learn? Collation projects take a lot longer to debug than you ever expected. Always, I say this very seriously, correct the input machinery, not the output. And you need to, if you involve your students, it's going to force clear communication from, oh my God. Okay, so now I'm getting to talk to you.
I thought we were at less than 10 minutes. I started the timer.
Yeah, oh, really? Yeah, it's only 9:25. Okay, we have 10 minutes now.
All right, well, Elisa, maybe you want to talk about,
I don't know, should I go back? Okay, so 3 more minutes. Okay, no, because we should talk about the spine. That was the critical apparatus markup that came out, the one XML file that holds collated moments of variance. That document is like a book spine, and it's also like a spinal column. And since this is Frankenstein, we get to talk about the making of a body or a corpus, yeah, all of that fun stuff. So it's coordinating our data on variance. It also makes it possible for us to output the edition files from one document. That's like kind of our TEI ground truth for the project, we generate the editions for the 5 documents, including one, and we stamp on those editions the information in XML about the moments of variance. And we're able to make synoptic views of the edition. And this is my favorite, the most recent production from all of our collation data on one screen, all 5 editions. And it makes possible, yes, but that one XML document that we were able to make allows us to see in an interface. And we click from one of these. You can go in here, mouse over, and find your way. And I don't want to lose my way in the slides, but you can jump from that heat map to one of these moments and see on the interface what happened at that moment, and jump from there to find out what this looked like at another moment in the edition. Right there. So we want you to be exploring that. And back to the slides, keep going. Go see our methods page for details, right? But we want to talk, I'm going to hand this to Raf to continue talking.
I'm Raf, and my main contributions to the project have been working together with Elisa on that TI data model for the spine, which I had the opportunity to also then apply to other projects because it's very useful to model variance without really having to, while keeping the representation of the sources separate from the collation itself. So it's quite a useful model. And I also focused on the technological stack for the website. But our third author here, Yuying, was one of Elisa's students, and she was the one who did a lot of the heavy lifting to sort of make it all happen. So we're very grateful to her in particular. And she's with us on Zoom, so she can also answer some questions in Q&A. So if you started visiting the website, you will see that when you started reading one of the sources at the very top, there is a kind of a navigation system that allows you to move between versions, choose a section within those versions, and then there are some display options. I'm going to go back to this in a second. As you're reading, you'll see that some parts are highlighted, and those are hotspots that indicate a certain amount of variance. If they're darker, there's more variance. If they're lighter, there's less variance. And the display options up here allow you to control some of that display. You can choose to hide them so that you can just read a cleaner text, or you can choose to hide the text, and then you're sort of left with a kind of a visual representation of what variance is happening, the amount, the degree of variance that is happening on the page that you're looking at, the chapter that you're looking at. As you click on one of these spots, you will get information about that specific variant. And so on the side, you will see how that text is changed or adjusted or modified in other sources. So here, for example, Of Eternal Light on the 1823 edition, clicking on it, you will see that the manuscript doesn't have that passage. The print editions agree, but in Thomas, it was revised substantially. And then by clicking on the title, on the name of the source, the view is switched. So now the main text that you're reading will be Thomas, and then on the side you will have the variants from the other editions. And whenever possible, we try to sort of like also link back to the other editions and resources that we've used to put this together. So for example, the Thomas edition has facsimile images at the Morgan Library Museum. So we add links to the right location, so you can click there and it will bring you to the facsimile image for that. We do the same for the manuscripts as well. Those links will lead you into the Shelley Goldman Archive project that I worked on at Method UMD. We decided from the start to publish this as a static website. And before I explain more about that, I'm going to make a short digression about how digital editions tend to be published at this point. Obviously, they need a server because they add it to the web. It needs to be made available on the web. There's often a database that contains TI and other XML, and then there's a web application logic that kind of negotiates between websites that your readers see and this database backend, so that if I can run queries and transformations on the fly to give to your users what they need to see. One of the issues with this kind of setup is that it is difficult to maintain for the long term because the database web application needs to be kept up to date and alive for as long as possible, and that requires resources and infrastructure. And James Smith is, sorry, who directed at the time when he wrote this article, the King's Digital Lab at King's College London, they were left with a lot of legacy projects, working at the department that worked for decades on these humanities projects, and they had to make some choices about legacy projects. And he wrote about it in this Humanities Quarterly article, and it says not all projects should be maintained in perpetuity. Some are not worth the intellectual, technical, and financial overhead of ongoing maintenance. And I think this is a useful thing to keep in mind. This is true. Some projects definitely have an expiration date, but who's in charge of this decision? I think that those who end up being in charge of this decision are those who are in charge of the infrastructure, like Smith is in this case, and they are determining in the long term the scholarly worth of a project, whether it should remain alive as form. And we as scholar creators may or may not be part of that decision. So in order to circumvent this situation as much as we could, we have opted to use a low infrastructure approach and rely on infrastructure as little as possible. So we decided to work with a static site generator because static sites, once generated, they are just a collection of files, HTML, CSS, JavaScript, that only require a general server, a generic server to be put online, and often you can put them on GitHub. We did. But it doesn't mean that this is less complex in any way than other digital editions, and I hope we sort of give you an idea of the complexity of this project. It just means that some of the complexity sort of moved towards the browser, and a lot of the work happens on your computers. This is inspired by the Endings project that they put together a number of recommendations for longevity of PH projects, and they recommend one of the core recommendations is using static sites. They recommend a lot more than what we follow, and minimum computing, which I won't get into because I'm running out of time. So this is our stack. We are using Astro, which is a static website generator, and Yuying set it up to create the routing for 146 chapters among 5 different missions. All of that sort of gets pre-generated, so that as you jump from a page onto the other, you're just looking at an HTML file essentially. And then I put together an Astro TI package to render the TI as HTML custom elements, which is based on a JavaScript library called Sedition that I worked on with Elisa at University. And we use React for the more interactive parts of the site, such as the selectors and breaking up the variants, so really looking into the spine. But all of those operations are happening directly on top of the TI because our TI is included through this Sedition approach. In the HTML pages. So yeah, that's kind of the quick overview. But this is the entire summary of technologies at each stage of the Frankenstein Variorum project. And the thing that I was talking about is it's probably just the one at the bottom. There is a lot more that has been happening in terms of collation process, modeling, massaging data, all of that. So it's not all, in JavaScript and around stuff websites. There's a lot of work that happens, like XD, etc. But it's sort of like part of the creation of the project, of the content of the data, and then the final website and the TI data itself is what sort of we intend to maintain for perpetuity, and we don't have to worry too much about things online. It's just a collection of documents. You want to conclude?
Yeah, my last probably 30 seconds. You cannot read this flowchart, but we were sort of saying, oh, look at this awesome display of complexity. To sum it up, there's XML, XSLT, Perl regular expression matching at the base of this, a lot of TEI document modeling, a whole pipeline of like 11 XSLT files and Python going back and forth to calculate edit distances. There's a lot going on here to prepare the data for packaging in React and JavaScript. But what we hope we've accomplished is an expression of the TEI in the browser and something that you can navigate quickly on mobile. So I want to encourage you to point your phones at this and explore it and tell us about it and tell us about bugs and things you want to see fixed. But we're very happy to have completed work on this project.
Thank you.